Good evening. I'm insert your name here. No, I'm Mark Donner. I'm the engineering site director for Uber in New York, and it's my pleasure to welcome you to our first ever public tech talk. I'm thrilled to welcome John Sarapata of Jigsaw. John is the head of engineering for Jigsaw, which is an Alphabet company. Is that the right way to say it? We're part of Alphabet. I'm sorry. I've known John for about a decade. We served on a hiring committee together at Google for most of the time that we overlapped. In that time, I learned to respect John's integrity, intellectual horsepower, focus, and ability to clearly articulate issues. John's title tonight is Jigsaw: Helping Users in Distress. And I'm not going to read out the text that was on the meetup invitation, but John, I'll just remind you that John has been at Google for a number of years and a number of other places before that, and has a bachelor's in physics from Caltech. I also went to Caltech, though, a number of years before John, so I know what he went through. All right, we're ready to go. So warm welcome to John.
So Mark, I don't know if that means I have to follow you to Uber in a few years, but so Mark's already introduced me. I have what I think is the coolest job ever. At working with Jigsaw, I get to do things like fight to end repressive censorship and try to stop online harassment. But before I dive into the technical details, I just want to spell out, since I'm an engineering manager, most of the stuff that I show you is actually done by a very strong team of dedicated engineers, PMs, UX, UI designer, community manager. Sorry, am I not loud enough? I'll hold the mic closer. Also, none of this would have been possible without the three principals who started Google Ideas, Scott Carpenter, Yasmin Green, and the president and founder, Jared Cohen. So without further ado, I'll give you a little bit of background of what Jigsaw is and where it comes from. So Jigsaw was formed as Google Ideas in 2010. If you remember back in 2010, Google was roughly 12 years old at that point. And in January, we announced the Aurora hacks, which was a foreign government trying to hack within Google. So at that point, it was clear that Google was now such a large global player that it couldn't separate itself from what was going on politically in the world. Around the same time, there was a State Department worker, Jared Cohen, who was leading the way, talking about how the internet was changing the world, how it could do good, what the new digital age would look like. And Eric Schmidt pulled Jared out of the State Department into Google to do what was a new experiment, form a think tank within a tech company as Google Ideas. So we started out with two missions that really continue on to this day. One of them was to advise executive leadership on what was going on and how we respond to it. The other one was to figure out how we could use technology to do good in the world in a very particular kind of way. So we believe that there are changes coming, that technology is disruptive, and some social problems can be helped by that. And part of what Google Ideas was supposed to do was find those ways and make them happen. As things went on, since this was a new experiment, originally it was formed as a think tank. They kind of realized that if you really wanted to take advantage of what Google could do, you would need an engineering team. So we've gradually been building up our engineering capabilities over the years. And when Google reorged into Alphabet, it kind of made sense to rebrand as Jigsaw and Incubator instead of Google Ideas, a think tank. We see our mission as helping users in distress. And when I say in distress, it's really users that are facing organized violence and abuse. So there are other parts of Google that will try to do things like help victims of floods or maybe fight flu. That's not us. Most of our problems have organized adversaries. So I'll primarily be talking about the engineering side, but Jigsaw has two fairly strong sides. There's a thought leadership side and an engineering side. The thought leadership side, you might have actually seen a very visible piece of work. They've been looking at ways to counter ISIS recruitment. So if you want to check out redirect method, it was actually an interesting idea. And the story behind that is we had been noticing that ISIS was very, very effectively recruiting people online. And if you did some searches for things like marriage and Islam, you would notice that the top search results would all be sort of radical or extremist websites. And we don't want to approach the problem by censoring, so we were looking for another way. And the redirect method is really just a way of running ads to try and contact these users. So the basics behind that would be, if someone searches for how do I travel to Aleppo, so it's someone that's already very actively looking at supporting ISIS, we might show them an ad that links to a YouTube video that shows what life is really like in the caliphate. And the interesting thing about this experiment is it stays true to our ideals, but it's actually very effective. So the ads that we run have a higher click-through rate than most ads that are run by a factor of 2 to 4. And once people look at one of these YouTube videos, they tend to watch for about 8 minutes. So we're actually able to take people that are seriously considering joining ISIS and fighting, and at least getting them to watch a moderate Islamic scholar or an alternative viewpoint for 8 minutes. And we think there's a lot of work left to do there, but we hope it's doing some good. So anyway, now into the engineering. So we do have a wide mandate in that Jigsaw will approach all sorts of problems like countering ISIS recruitment. We've done work in the past to counter human trafficking. But on the tech side, we mostly focus on free expression, just because that's where we can get the most benefit. So I'll give you a Jigsaw view of how we fight for free expression. At the very top would be you and your phone or your laptop. It's the people who read and create content on the internet. In the middle is how you actually get information. And I've separated find and transfer. For people that are familiar with internet protocols, think of find as DNS and transfer as the TCP protocol. And the reason I separate them is that they have very different vulnerabilities and very different attack vectors. And it's something that comes up over and over again. So I've sort of phrased this as DNS and TCP. If anyone here is a Tor user, you can think of the finding as knowing what the IP addresses of your bridge nodes are, and then the transfer would be the onion protocol itself. And it's just a repeated pattern. And then at the very bottom is the server that hosts the information. And there are different attacks. So at the top, really, governments are talking about silencing people. So if they're doing surveillance, if they're phishing you, if they're trying to connect the social networks, to see who's talking to whom, if people are trying to physically attack you or compromise your hardware, that top layer is mostly about stopping people from creating the content and intimidation. The middle layer for finding the information in terms of censorship, you have all sorts of DNS attacks. So you'll see DNS poisoning, DNS hijacking. In the transfer, there's a little bit more flexibility. Maybe you completely black hole an IP address. Maybe you detect the HTTPS protocol on the wire and block it. And then finally, at the server level, you'll try to perform a DDoS attack. So you'll send so much traffic against a website that you actually knock the website offline. And if you look at this, clearly the biggest space is on top. That's where the most flexibility is. But from our viewpoint, we really have a lot to gain and the other two. So each one of these represents a spun up team for us. One thing I want to call out, again, talking about DNS attacks, is that this is not a Google team. But with the power of the internet, one of the first countries that tried to censor was Turkey. And Turkey actually changed DNS entries. So if you went to search for certain websites, you couldn't find them. And this is an amazing bit of graffiti, because Google at the time had released a product called Google Public DNS, And the IP address for that was 8888, and we also have 8844. And the idea was simple, was that we had noticed that providers and governments were starting to mess with DNS, and we wanted to have an authoritative alternative for people to go to. And the amazing thing is, in Turkey, people realized that you could use Google Public DNS to bypass the censorship. And this is graffiti. So I think the fact that you have graffiti, spray painting an IP address to fight censorship is one of the more interesting things that shows how what we do is valuable and how tech actually helps countries go through change. All right. So the next thing I want to talk about is why. Like, why do we care about freedom of information? And when most people talk about censorship circumvention, I think the idea is you have a user sitting behind a firewall and you want them to get access to the global internet. And the mental model that people have is almost like if we just let people in North Korea read the New York Times, then there's going to be a popular uprising, which it's not really something that makes a lot of sense in practice. So I want to talk through a motivating example, like why do we do this? Why do we care? This is a series of people mourning deaths from the 2008 earthquakes in Sichuan province in China. So just to give you a little backstory, there were big earthquakes that were just a tragic loss of life. About 70,000 people died. One of the most painful parts of that was that 5,000 of them were children because many schools collapsed. So it was just a big, big disaster. And initially, the Chinese government even tried to deny that an earthquake had happened, but people had posted photos of the earthquake and of the collapsed schools, so it was impossible to deny the truth of what happened. But even more powerful than that is that because we had schools collapsing and because of the one-child policy, many families lost an entire generation, and they wouldn't let the issue rest. They wanted to get to the bottom of it. And as people started investigating, one of the things that they found out was that the reason the schools collapsed was that they were built from substandard concrete. And the reason they were built from substandard concrete was that the contractors had bribed the officials to allow them to not live up to the code that the government had said was necessary. So it really shows the power that letting people talk to each other has to expose corruption. So that's where we go to the next step, that it's not about people reading content, it's about people also generating content. So we want people to be able to talk to each other and have discussions. And I still have the global internet outside the firewall because it's useful to have a place where people can talk and not be subject to interference. So it's nice to be able to get away from your country's control, just to be able to discuss things. This isn't foolproof because what happens if the country seals off the external internet entirely? And we're actually realistically at this point in many countries. North Korea does not have much access to the internet, but, and we just saw, I think in the Gambian elections, they shut the internet down completely. But even in China, the external pipe isn't completely shut off, but it's slow enough to degrade service that people just end up going to local services. Like, why would I use Google if I need Baidu? Why would I need Facebook if I can go to Weibo or one of the local services? So we're ending up in a situation where governments are actually cutting off ties to the global internet. So we really need a way for people to be able to communicate with each other internally inside the firewall. And this is something that I don't think is a solved problem. People have talked about mesh networks a lot. And mesh networks have never really lived up to their promise. There's also, if you look at countries like Cuba, they had a very interesting system called paquettes, where they didn't have live internet, but every week you would get a thumb drive that had sort of the best downloads. And they even had dating apps and classified apps built on top of it. So there are ways of working around this, but it's one of the ongoing challenges that we face. So anyway, now I'll start walking through the original graph and how we're addressing from the content creation down to the server. One interesting project that we put out is Unfiltered News. This is still in beta, but you can actually get to that website. The URL is just unfiltered.news. And it's an interesting idea. Every time Google scans a news article, we will mine it to see which knowledge graph entities. Knowledge graph is what we call our organization of knowledge. So if you've ever searched for a movie and you see a panel on the right of the search result that has the movie, the actor, the directors, all that's organized into a collection of bits of knowledge. And when we scan news stories, we look for that, and it's knowledge independent or language independent. So the interesting thing about this is what we can do is say what people, events, countries are being discussed everywhere else in the world except your country. So it's a way of sort of puncturing filter bubbles. It's finding a way of stories that everyone's just agreed not to report on. And I encourage you to go play with this. I think the most interesting example, if you go back in time, is back when the Panama Papers broke, everyone was talking about Mossack Fonseca, except Russia and China. So in a lot of cases, you can find a lot of interesting stories. For anti-phishing efforts, a lot of what we do is not direct engineering efforts of ours, but we try to take advantage of everything that everyone else in the rest of Google is doing. So we've been able to take advantage of some great stuff that our security team is and make it available to the public. And the first is password alert. So for the longest time, Google had a program that internally I think we called Watchdog, that was a simple idea. It would look for cases where you entered your password for your corporate account into a website that was not a Google website. And this turns out to be a very common phishing technique. I think it's the technique that caught John Podesta, that they had him go to a link and enter his password, but it wasn't the real site. So at Jigsaw, we realized that, that watchword wasn't going to work for the general public because we were all Google employees on Google hardware. We were very comfortable with Google having a lot of information, but we needed to have a much tighter control. So we modified password alert to make it easier to translate it to not send any information back to Google. So I think we've got about 1 million downloads now, but this is something that will actively prevent people from phishing your Google accounts. Another thing that we've done, which actually got a bunch of press a couple weeks ago, is the government attack warning. So we have a great team at Google that's monitoring hacking threats. They want to know people that might end up hacking Googlers. So they're seeing what hacking capabilities are out there. And as a side effect of what they're doing, they can see when people are attacking Google accounts. So one of the things that we've done is when we've detected that one of these state-sponsored hacking groups is attacking any Gmail account or any Drive account or any Docs account, when you log on, we'll give you a little warning message, an interstitial here, telling you that a government is trying to attack your account. So you can find out what it means. It'll tell you what to do about it. Probably don't open PDF files, don't plug in USB drives, use two-factor authentication. But if you ever see this dialogue, don't ignore it. It doesn't necessarily mean your account was compromised, but it means someone's trying. All right, now I'm going to move into our efforts where we have staffed up engineering teams with longer running engineering efforts. So conversation AI started with a very simple idea, and that was that discussions on the internet weren't always civil. And we really thought that there was power in people being able to talk to each other and resolve differences. And we thought that we could use machine learning to improve the discussions. And honestly, people are fighting against us. If you look at the news recently, there are all sorts of troll armies. China has the 50 centers, Russia has the troll armies. Those were the earliest, but I think we've documented now at least 20 or 25 different governments that have organized groups of people that are trying to get online and distract from the conversation, push pro-government propaganda, sometimes harass people and try and silence them. And this is being amplified by bots. So mostly this is government driven. There are also brigades that are non-government driven, but we really like to get a handle on all of this. And we're starting right now at the conversation level, at the post level, but hopefully we'll be able to expand our reach and do a little bit better on this. One of the things I think that's really important is there's a big tension between fostering discussion and stopping hate speech and censorship. So we really have built into our DNA that we do not want to hide information. We do not want to hide things. But if someone is threatening to rape you online, if someone's threatening to murder you, we have to think about what to do about it. So when we're dealing in morally ambiguous waters like this, it's very, very important to lay out your values. So when you move forward, you know what you value, what you want to do. And the team did this. And two of the values that I want to call out as being very important is one, that when we work on conversation AI, we very much see this as being community specific. So we have no intention of being a global model that is a political correctness police. If we do that, then we've failed. We really think that what we want to do is let every community decide how that community wants to be and enforce it. So if you have a community where you only want to talk about puppies and everyone's nice and nobody swears, that's great by us. If you have a community where it's a little bit rougher, you tend to give people a hard time and swear, that's fine by us too. We want you to be able to set whatever you want and support that. And we think one example of someone who does this really well is Riot Games. If you looked at League of Legends, even though gamers take a bad rap as kind of being rough and tumble, I think that they've really done a fantastic job of maintaining community standards and civility, not just around how you talk to each other, but around gameplay. And that's something we'd like to emulate. So what we're doing is we're doing machine learning, and we joined forces with another team at Google that had been looking at doing similar things with YouTube comments. So we've actually been at this for a year, and we've started getting some promising results that are starting to ship. So I'll talk through some of the partners. The key thing about any machine learning is you need data, and thankfully we have lots of sources of data. So with YouTube, they really wanted to clean up their comments, and they've recently started sending out a feature where channel owners can look at the comments that they provide. And this has been very popular so far. And the idea there is that if you have a video, if you have a channel, and you get 100 comments, we might flag 10 of them as being suspicious. The other 90 will go through. The next time you log on, you'll see a message that says 10 comments need your approval. And you can look at those and say, no, let them through, or no, block them. And this has actually been tremendously popular. The next one is Wikipedia. And Wikipedia, I think, really shows the power of machine learning and the way our world is changing in terms of capabilities. Because Wikipedia's core problem is that fewer and fewer people are editing Wikipedia pages. And a lot of times what happens is you might view a Wikipedia page, say, I have better information or I have a better source. You go through the trouble of setting up an account, you add the change, and you're going to get something on your talk page that says something like, you're an idiot, you don't know what you're talking about, go home. And for the casual user, they're just going to say, look, I was just trying to donate my time, I don't want to put up with this abuse, and I'm going to leave. So it's a real problem for Wikipedia because they're getting fewer and fewer editors, they're getting fewer and fewer edits, and Wikipedia needs to benefit from everyone's knowledge. So we actually were able to apply machine learning models where our models can identify abusive talk page edits more accurately than the average of 10 human raters. So we think that we're only scratching the surface in terms of what the machine learning is capable of, but we're already outperforming the human beings. And we presented this at the Wikimedia conference, and we're sort of moving forward with trying to help them out. But I think this shows the power of what computers can bring. And then finally, on the New York Times, this is also a partnership that was announced. The main issue that the New York Times has is that every single comment that shows up on their website is human moderated before it goes live. And they have a full-time staff of moderators, but those moderators can only handle comments on about 10% of the videos and articles. So what they just do is turn off comments on the other 90%. And what they would like to do is see if machine learning models can improve their effectiveness so they can turn on comments on all the web pages. So we are far enough along with their training data. They gave us fantastic training data. We can actually take a comment, and one of the canonical examples that our PM always gives is that I can say the phrase, I think you are full of shit. And that's gonna say it's very aggressive and it's personal attack. If I say, I think I am full of shit, our models will say it's very aggressive, but it's not a personal attack. So we have all of these detection methods where we can see, is something obscene? Is it a personal attack? Is it off topic? Is it unsubstantial? And really fine tune what's allowed on the site. And we're seeing very, very promising results with the New York Times data. I mean, I don't have anything to announce, but we're pleased with where this is going. But even more importantly, we would like to extend this and bring more people in. So hopefully you'll be able to see more civil discussion. All right, the next effort, moving down, how are we doing on time? Oh, perfect. So moving on down to the wire transfer. Our Firehawk team is the team that's aimed to do censorship circumvention. And for a long time, one of our earliest engineering efforts, I think, we've been working on a peer-to-peer proxy called uproxy. And I'm going to be talking about that more later on. But one of the things that we've been struggling with is that Eric Schmidt gave us the marching orders. He said, end repressive censorship in 10 years. And we've been thinking as a team, like, do we think one browser plugin is going to end repressive censorship? And we're not convinced it will. We think that we need to set our sights higher. We're learning as we go. We're trying to build up. But one of the things that we think is important is that we need to start looking at the whole ecosystem. How do we bring the internet along with us? Can we help standards become with censorship hardness? Can we build censorship hardness into platforms like browsers or OSs? So the team is really changing focus right now, which is why we used to be called the uproxy team. Now we're called the Firehook team. So a firehook is something that's used by firefighters to scale walls, and that's how we thought it was fun. So now diving into some of the specifics around tech, around censorship circumvention, I have to apologize for the people that aren't good with network security. This might go a little bit deep as we go on, but hopefully it's all fun. So the way most people address censorship is with proxies. And you can see here, in the one case on the top, YouTube is going to the users. It's very, very easy to cut the wires and say, anyone going to YouTube, we're going to block it. The way that you normally respond to that is to have a proxy server. So now from the censor standpoint, this is no longer coming from YouTube. It's coming from the proxy server. This, I think, is the most common use case in like Turkey and China, where you'll have a VPN. And the problems here are really twofold. One is, if you have one VPN, then I can cut the connection to the single VPN, just like I can cut the connection to YouTube. So there's a single point of failure. There's also the issue of wire protocols. So there are capabilities, if you're performing DPI, you can detect any VPN connection and just say, I'm not going to allow a VPN connection. So we're really dealing with two issues where we need to have many different proxies to make it harder to block. And we also have to hide what the traffic looks like. So with uproxy, it started with a fairly simple idea, which was, at the time, browsers were starting to have, for the first time, a technology called WebRTC built in, which is a peer-to-peer technology. It's the same technology that's used to perform video chats, perform BitTorrent. So the possibility was we could allow peer-to-peer proxying. And the fundamental idea would be, if I'm sitting in Turkey, if my friend is sitting in Germany, I can ask my friend to proxy my connection, and now every bit of my internet traffic is going through him, and I'd be able to see the internet as if I was in Germany. And we would be able to do this taking advantage of a browser extension, which means it would work on every platform. There are a lot of difficult concepts there. I won't go into the alphabet soup, but one of the interesting ones that I want to call out is collateral freedom, that almost every circumvention technique uses what we call collateral freedom. And the idea there being is, you can't block one website without blocking a website that you want. So the end goal of that would be, you couldn't block anything without blocking the entire internet. But you'll frequently see services like Greatfire, if any of you have heard of it, will route the New York Times through Amazon, which means you can't block the New York Times without blocking Amazon. So people end up with these games where you try to increase the collateral damage. So we force people into this debate where maybe there's an embarrassing YouTube video of me dancing funny, but if I cut that off, I'm going to lose Amazon, which is going to cost my economy $2 billion. So I can live with people seeing me dance funny for $2 billion for my economy. And that's really the calculus that we're trying to force people into. So more into other concepts for circumvention. Surprisingly, the technique that works most right now is a side effect of a standard, and it's called domain fronting. It was pioneered by a researcher named David Fifield out in Berkeley for the Meek pluggable transport for Tor. And the idea is a straightforward one. When you have an internet connection, your browser is going to first look up the host name to get the IP address. Then it's going to connect to the IP address. If you're using an HTTPS connection, it's going to encrypt things, at which point everything goes blank. And once it's encrypted, you then request the individual web pages you want. And the magic ingredient here is that you have CDNs that serve many, many web pages. So someone like Cloudflare or Akamai isn't going to host one website. They're going to host a number of websites. So in this example, the CDN is hosting a loud host and blocked hosts. And what you would do in your computer is you would look up the DNS entry for a loud host, connect to it, initiate your encrypted connection so everything's blocked. And once you're encrypted, then you go to the blocked host. And there's really no way of fighting this unless you want to block all encryption. So it's a clever idea, but it's a side effect of the standard. It's not built in. We would really like to encourage sort of more robustness going forward. The next thing I want to talk about, which is very interesting and kind of segues into the final part of the talk, is the Great Canon. In spring of 2015, China weaponized the Great Firewall. That's a little bit simplified way of saying it, so I'll dive into it a little bit more. There's an organization I already mentioned, Great Fire, that was using Amazon and also GitHub to domain front New York Times. I know there are a lot of buzzwords there, but I hope everyone is still remembering. And we'd already seen that China was reluctant to block GitHub or Amazon. In fact, they tried to block GitHub, and there was so much uproar in the country that they had to turn it back on right away. So the Great Canon was a response to not being able to block GitHub or Amazon. And basically it's saying, if we can't block those websites, we will launch a denial of service attack on them. And the way that Great Canon operates is that if you're a user who's browsing a website that's within China, and in this case, it was a website that was using Baidu Analytics, which is similar to Google Analytics. It helps people, Chinese language, track their websites. Then 1 out of every 100 loads, instead of giving you Baidu Analytics, would actually insert malicious code on your computer. They would give JavaScript that once every 10 seconds would ping one of these sites to try and DDoS attack. So what happened is anyone, mostly Chinese language speakers, who was outside of China reading Chinese language news would get turned into an unwilling botnet to DDoS these things. And one of the things that's interesting, I highly encourage you, if you're into network security, Citizen Lab put out, I think, the best paper ever on this. And it's a little hard to get into, but if you read it, it's amazing. I definitely check out Citizen Lab's Great Canon paper. But one of the things that they were able to prove is that the Great Canon wasn't actually the Great Firewall. They were machines that were co-located with the Great Firewall, and that they're the same number of internet hops away. But there's a big difference. The Great Firewall is on path, but it's not in path. So if you're looking at the Great Firewall with censoring, there's going to be a machine off to the side that's monitoring your traffic. And if you get a banned word, then that machine is going to send a TCP reset message to both the server and the client, effectively terminating the connection. But you still have a direct connection to the server. It's just that there's a machine off to the side listening to you. With the Great Canon, in order to be able to substitute content in line, it actually had to be in path. So it's now sitting in the middle. It's no longer sitting on the side. And initially, at least, because you need to be much faster, it was a simpler lookup mechanism. It didn't do something as complicated as reconstructing a TCP stream. But what's interesting is that recently we started to see reports of people that are where they're seeing different pages based on who's browsing, which is interesting because the first time we saw the Great Canon, immediately people realized it could be used to inject malware. So in this case, in the case of the Great Canon attack in 2015, it was really attempting to do a DDoS attack, so it was causing your computer to load web pages. But it always had the capability that we could load an exploit, like a 0-day, that would actually take over your browser or take over your account. So when you combine with that the ability to specifically target web pages at given IP addresses, then the government has the ability to say, this is your IP address. The next time you try to browse Baidu, we are going to send a custom page that takes over your computer. So it's a really powerful hacking technique. So now I'll move into our DDoS attack. So we've gone through The top, which is you and your computer, the middle, which is the wire transfer. And at the bottom, we're trying to protect servers from DDoS attacks. One of the first outputs that Google Ideas had was digitalattackmap.com, which is something that we did in conjunction with Arbor Systems. And what we do is look at real network traffic to see if we could show you DDoS attacks in real time. And you can go to that website now and see what's going on, just to see what's fun. But one of the things that's interesting is that we noticed that attacks in the digital world very much mirrored attacks in the physical world. So whenever we saw unrest, whenever we saw physical unrest, we saw it mirrored online. This is showing the Euromaidan protests. This is when the Ukraine had a president who was pulling them out of an agreement to enter the EU, and people went out onto the streets, and the protests were so heavy that that the president ended up resigning. But you can see there was very, very heavy DDoS traffic. One of the things that's great about this, and it really shows sort of our ideals as Jigsaw, is that during these attacks, we were protecting websites on both sides. So there were Russian papers, or there were people that were pro-Russia, pro the president. There were people that were pro-Euro against the president. Both sides were getting DDoS attacked, and Project Shield was protecting both sides. So it really sort of highlights one of our ideals, is that we don't want to take a side in anything, but we think that certain techniques should not be allowed. So shutting down a website by sending it too much traffic, that just doesn't seem to be playing fair, and we have no problem shutting that down. Which is similar to our thinking about conversation, which I'd mentioned earlier on, that when you have hundreds of people saying you're stupid, go home, it's almost like the human equivalent of a DDoS attack. But just a couple more examples. This is in Thailand, when there was serious unrest and people not happy with the king. And more recently, this was the umbrella revolution. So I don't know if you remember this, but Hong Kong had a referendum once where they really wanted to push self-determination as they were getting absorbed back into mainland China. And they had actually scheduled a vote to demonstrate that they had support for this. And there was massive, massive online activity where that was going on. And we were also protecting some of the umbrella revolution sites. All right. So the way that we're protecting them is something called Project Shield. And Project Shield, we almost got into it by accident. Google had released a project years ago called PSS, Page Speed Service. And one of our PMs had the clever idea that Page Speed Service we could use as DDoS protection, that if we host news sites on PSS, then they'll automatically benefit from Google's DOS protection, but also we can sort of scale them up by allowing more machines and give them more capacity. And we set up a sign-up flow. So what we said was, if you're a news site or a site based on elections or human rights, then we will protect you for free behind Project Shield. This changed a little bit when Google announced that they were going to turn down paid speed service. So we actually spun up our own backend. The latest instantiation of Shield has been live since February, and we're sitting on Google Cloud Platform. We're running Nginx proxies, and we really take advantage of multiple layers of protection. So at the top of it, we have DOS Server, which is Google's DOS protection. The other thing that we have is scalability. So what we can do is go from 2 VMs to hundreds of VMs, and we can scale up our capacity very, very rapidly. Probably provide more containers than the website could on their own. And then the final thing is, from the reverse proxy, we can play a lot of games. We're using Nginx, and most DDoS protection involves being clever about caching and rate limiting. And we sort of play all those games. Also, Nginx has some built-in things that help with DDoS attacks, like cookie challenges and JavaScript challenges. So this kind of hit the news right around September 21st. This is Digital Attack Map, a screenshot of it from September 21st. What happened was, around that time, there's a website called Krebs on Security, And Krebs is known in the community for constantly fighting against DDoS attacks. And in fact, he had gotten a couple perpetrators of DDoS jailed. There's a very active community of people with DDoS. You can go online, you can look on YouTube, and for as little as $50, you can pay people to take down a website. And we've also noticed, sort of tracking this, that there's a little bit of an extortion racket. So the same people that are actively trying to take down websites are selling DDoS protection services. So part of what they're doing is saying, we won't take down your website if you pay us. And we actually noticed this in particular with Krebs. There was one Twitter user who was offering DDoS and also bragging about being about to take on Krebs. So anyway, Krebs was a target, and he saw he was being hosted on Akamai, and Akamai announced it was the largest DDoS attack they'd ever seen. They announced 620 gigabits per second, and Akamai was able to survive the attack, but they told Krebs, we can't do it for free anymore. It's too big. And Krebs needed to find another solution. So Krebs ended up coming to us, which was tremendous fun for us. Our PR people told me I shouldn't talk about attacks as being fun. But it was very high profile, and it was a chance to take a young system and a young team and really stress test them to see what was going on. It turns out that what was happening was, for the first time, people really exploited the Internet of Things. Basically baby monitors. So someone had figured out how to get into a bunch of baby monitors with default passwords and use them to launch denial of service attacks. And when we finally got a chance to look at this traffic, it turned it into a botnet that was roughly twice as large as the largest botnet we'd seen previously. And since then, the source code for this botnet has been released, and it's been named Mirai. Since the source code has been released, pretty much any script kiddie can run it. And this is the botnet that was behind the attacks on the Dyn DNS service that ended up bringing down Twitter and Snapchat. So anyway, we brought on Krebs, and since this has happened, since we brought him online a couple months ago, we're seeing roughly 5 attacks a day. And like I said, it's a stress testing. Everything they can throw at us. We're seeing brute force attacks, slow LoRa's, cache busting attacks. One of the ones that was successful early on was Hulk. And one of the fun things is, we were actually able to follow one of the Twitter users who was bragging about bringing the site down. And that's how I know that this person was both selling DDoS services and trying to bring down Krebs. So there was a little bit rough going in the early on. And I just want to give a shout out to Google services. The massive attacks, the 500 gigabits attacks, we just sort of shrugged off. Like Google services, we don't even notice. The attacks that succeeded were the ones that got to our new service that was only launched in February. And that was mainly things where what we want to do is we don't want to bring the site down. So if we get too many requests, we'll stop asking the site for requests and serve pages saying the site is over limit. There have been too many requests. So although we kept the site up, we were serving error pages to users, which wasn't great. So the bottom line, though, it wasn't so bad. We had, I think, a total of 9 hours outage in the first 2 weeks. And we've gone a period of 3 or 4 weeks with no outages. So for us, it was a great learning experience. We got to see where the holes are. We sort of had a free chance to get one of the world's top booter services throwing everything they had at us. And through it all, through the first 2 weeks, even though we had some downtime, we managed to keep Krebs up 99.5% of the time. So we had, this was entertaining for us. It was good for our system, and it was also good for Google's SREs because they had a chance to explore this new emerging threat without actually having Google services at risk. It was a third party.